Welcome to Temple AK Academy, and welcome to the mathematics section today. We're looking at a very interesting topic, standard forms. Standard forms are alternative forms of representing decimals. So I recommend you look at my video on fractions and decimals. Let's get straight off into it. So a number is said to be in standard form if it can be written with in the form k multiplied by 10 to the power n. This is the general form when we have the number in standard form. The number k must be such that there is a non-zero digit, only one non-zero digit before the decimal point. So k must be a value that lies between 1 and 10, greater than or equal to 1, but certainly less than 10. Of course, n is any integer, positive or negative, a whole number. So values like 1.0, 1.1, even chains of values, 3.172 allowed, so long as we have a single non-zero digit before the decimal point. K is allowed. Up to the value 9.9. So a single digit that is not a zero before the decimal point. N, of course, is any integer. It could be positive or negative. Let us look at some examples of figures that are in standard form. So we have something like, if I'm right, 3.125 multiplied by 10 to the power 6. This is in standard form, of course, because right here we have only one digit, a non-zero digit before the decimal point. And then we have the chain of other values. And of course, you can see we have the appropriate power of 10. This is standard form, of course. This number is said to be in standard form. All right. Now we can write again 9.27836. As you can see, the chain of figures will not change anything. We can have times 10 to the power minus 9. This again is in standard form. Yes, of course. Before the decimal point, there is only one digit that is not a zero, a non-zero digit before the decimal point. Now, it doesn't matter the chain of digits following it. And we have the appropriate power of 10. This time around, the power of 10 is negative. So this is in standard form. What are examples of numbers that are not in standard form? If we have 72.68, for example, multiplied by 10 to the power 4. This is not in standard form because now we have two digits before the decimal point. So this is not in standard form. Okay, let us move on deeper into the topic. That's right. And it's time for us to begin to look at examples. So let's go. Here we are. So I need a better color of marker now to get into this. Let's take the traces out of the way. Here we go. Express this number in standard form, 27560. We follow two steps. Step 1, move the decimal point to the appropriate position. So step 1 is to move the decimal point. So you can take note of this. Move the decimal point. Move the decimal point to the appropriate position that makes the figure to be standard. Move the decimal point to the appropriate position. And what's the appropriate position? One non-zero digit before the decimal point. Okay. Number 2, do a restoration of the original value. A restoration of the original value. So 2 steps. And now let us practicalize the steps. Okay. So let me take 2756000. Locate the decimal point. Where is the position of the decimal point here? Anytime a figure is written and the decimal point is not shown, it means the decimal point is at the extreme right of the figure. That's the position of decimal point. Now, the first step is to move that decimal point to our desired location or position, and that is one digit that is not a zero. Correct. That's it. So if we do that, the value of the figure will change into 2 with the decimal point, 756. And now this chain of zeros at the back of the point are not significant. So I could just exclude them right now. Good. Now the second step is restoration. So let us return the decimal point. We have moved it here. Let's return it to where it was from beginning. Restoration move. So step 1, move the decimal point to desired location. Step 2, do a restoration. And then restoration of the magnitude. So we have to now have, because look at this, 2756000 is different in magnitude from the new writing 2.756. And therefore we have to restore the original magnitude. That restoration is by multiplying by the appropriate power of 10. How do we do that? Multiply by the appropriate power of 10. Let us see. In the restoration move, the arrow points right way. In the restoration, the arrow is right way, directed towards the right. Towards the right means it is a positive move. And therefore, our power of 10 will be positive. So we have how many digits in between the moves, in between the two positions of the decimal point? 1, 2, 3, 4, 5, and of course 6. So we have positive 6. And here we have the standard form. Very simple. To achieve cognition in the students, it is my usual practice to furnish you with examples. Repetition will guarantee cognition. So series of examples. Relax, it's not time to judge yourself. You're going to understand it fully. Let's see more examples. Patient with yourself. More examples. Here we go. All right, another one. Let's take the traces off. Express 1248.91 in standard form. Let's go. Let's get into it. 1248.91. Let's get into it. So I'm going to have to write this. 1248.91. Step 1, let's recognize the position of the decimal point and move it accordingly. The decimal point position is right here. Now let's move it to desired location. To standardize this figure, the decimal point needs to be immediately after the first digit, which is not a 0. That's the position of the decimal point, which will make us write a new magnitude. Now remember, the decimal point is no longer here. The decimal point has relocated after the 1. So we have 1.248, right? Every other digit without showing the decimal point. It is in a new location. Good. Now, if you compare these two values, first value and the second, their magnitudes are different. So here comes the restoration. By restoration, return the decimal point to its original position and study the movement. Is the movement towards the right or towards the left? Of course, towards the right. A rightward move means a positive power of 10. So we have times 10 to power. We're expecting a positive value here. But how many movements, how many digits in between the two positions? 1, 2, 3 in between the positions. So we have 3, positive 3 as the power. Final answer. Very simple. So this is how to express the number in standard form. The high points, once again, recognition of the original position of the decimal point, relocating it to the desired position, 1 digit, which is not a 0, before the decimal point. Then the restoration, returning, making a move that returns the decimal point position to where it was from beginning. And now taking stock of the number of digits that we have to cross in that process. Finally, giving the sign, positive or negative. Positive when the movement restoration move is on the right, negative when it is on the left. Our final answer, very simple. More examples. Let's take another one. That's right. Here we have another example. So let's, these traces give way. So let's go. Let's get into this. 0.000134 in standard form. So let me take a moment to write it. I'm going to write it again. 0.0001 3 with 4. Now, step one, recognize the position of the decimal point. That is the decimal point. Now, return it to desired position. Standardization involves having the decimal point just after one non-zero digits. That's right. And now you can see, when you study significant figures in one of my videos, you see that this chain of leading zeros are not significant. So we can exclude them in writing. If the decimal point is in that position, then they have no value. So we have the new figure to be written is 1.34. Now, as you can see, there is a large difference between the new magnitude and the original magnitude. Now, restoration is required. Return the decimal point position to its original position. That's right. Return the decimal point from its new position to the original position. And take note of the direction of that restoration move. The restoration move is towards the left. Yes, towards the left. You can see that. You can see that. Towards the left, which means we're going to multiply by a negative power of 10. Leftward move means negative power of 10. How many digits in the move? How many times did we cross over? How many times? Let's go for it. 1, 2, 3, and of course, 4. So negative 4, our final answer. Very simple. Once again, move the decimal point position to desired location after one non-zero digits. Then write the new magnitude, 1.34. Get ready for the restoration, times 10 to an appropriate power. Now, return the decimal point position to where it came from. Take note of the restoration move. Leftward, negative power. Right way, positive power. In this case, the restoration move is left way. You can see that. And that guarantees the negative power of 10. Now, what will be the figure here? The number of digits in between the new position of the decimal point and the original position of the decimal point. The new position of the decimal point and the original position of the decimal point. Let's count. 1, 2, 3, 4. And that is why we have this 4 around here. Very simple. Let's move on. Please come with me and stay with me. Another one. Another one. This video is not designed for entertainment. It is for full learning. As you can see, series of examples to posterize the learning. Pause the video at any moment and study the example. Repeat the example until you master it. So let's look at this. Here we are. 0.00055. That's right. And now we want to standardize this. Move the decimal point, of course, to the desired position. Can you figure out the desired position? You can pause the video to find it out, figure it out. Yes, that is it. One digit that is not a 0. So the decimal point should find its way there. And that means this chain of beginning or leading zeros are insignificant, and we're going to exclude them. So we write 5, first digit, non-zero, with the new position of the decimal point, 0.5. And you can see 5.5 is different in magnitude from 0.0055. Here comes a restoration to normalize the value or restore it to its original value. Let's go. Multiplication by the appropriate power of 10. Let us now see. Restore now. Move the new position of the decimal point back to the original position. And what is important now? The direction of that restoration move. You can see, as you can see, the restoration move is towards the left. That's right. Look at it. Look at it. Towards the left. Towards the left means a negative power of 10. What figure will we have here? The number of digits in between the two positions of the decimal point. 1, 2, and 3. So we have 3 around there. It's getting exciting, of course. Final answer. Very simple. Let's move on. All right. Okay, so let's get these traces out of the way. Now, this is more business-like. This is more business-like. Let's see. So we have x is given to us as 8 times 10 to the power 4. That is in standard form, of course. Y is given to us as 1.0 times 10 to the power minus 3. Z is given to us as 0.00004. That is not standardized. Now, the examiner wants us to evaluate x squared y divided by z cubed, and we're expected to leave our answer in standard form. This is a typical exam type question. Let's get straight off into it. We know the value of x, standard form already, 8 multiplied by 10 to the power 4. And we know the value of y in a similar manner. Y is 1.0, which I can write as 1 times 10 to the power minus 3. And now let's take a moment to standardize our z. Okay, would you like me to give a better sign here? Of course, and why not? You deserve it. Why not? That's it. Now z can be standardized. Z can be standardized. How do we standardize what we've learned? This decimal point needs to go over there, right? So that we can have 4.0. Then normalization by multiplying with the appropriate power of 10. What will be the appropriate power of 10 here? Restoration tells us that we should take the point back here. And that is left move. Left move means negative, as we have learned. How many digits? 1, 2, 3, 4, and of course 5, because the position of decimal point is here. So negative 5. Now we have x, y, and z in standard form. Let's get into the real problem. We're expected to find x squared y divided by z cubed. Let's get into it. This means substitute given values. The value of x is 8 multiplied by 10 to the power 4. All this must be squared because we have x squared in the expression we're trying to solve, multiplied by ordinary y, which is 1 times 10 to the power minus 3. Now divide by z cubed, and we have to substitute the value of z at this point. The value of z is given to us already, we know it. So let's get 4 times 10 to the power minus 5. And now where is the cube? To the power 3. This is the new face of the problem. Now, it's expected that you have studied some indices. You can look for my video on indices. Of course, this channel has video on indices. Find it, study, and get understanding. Now we're going to have to evaluate each of these powers. So we continue. The power 2 will be distributed to each part. 8 has to suffer the squaring, and of course 10 to the power 4 after laws of indices. 8 squared, 8 multiplied by 8, that gives us 64. And now multiply by, this time around, we apply that law of indices that says a to the power x, once again, raised to another power y, means there will be multiplication of these powers. So we're going to have a to the power xy, a law of indices. And that means we're going to have times 10 to the power, the 4 we simply multiply the 2, 4 times 2, and that is 8. Mission completed around here. Multiply by, we have another component in the numerator. Let's show respect for it. 1 times 10 to the power minus 3. And now evaluation of the bottom. So let's go. The same rule. 4 will have to be raised to the power 3. So 4 to the power 3. 4 multiplying itself 3 times. 4 multiplying itself 3 times gives us 64. 4 times 4, 16. 16 multiplied by 4 is 64. You can figure that out. 4 multiplying itself 3 different times. Let's go. 4 times 4 is 16. The 16 resulting times 4, 64. And here we are, multiply by that same law of indices. Do you remember? The 3, we have to multiply the minus 5 here. So 3 times minus 5 gives us minus 15. That's right. How do we do this? Let's make it easy. 64 can divide through 64. And now the mobility rule, as I discussed in the video on indices, the mobility rule. Anytime an expression in the denominator moves up to join in the numerator, the sign of its power will change. So this expression can be written as the numerator that we have here is 10 to the power 8 multiplied by 1 times 10 to the power minus 3 And let me create some space there. No interactions from here. So yes, smooth right now. And now 10 to the power minus 15 goes up in the numerator with a change of its sign. So we have 10 to the power positive 15. That's right. So mobility of a term in the denominator elicits a change of the sign of its power. And now the final knockout. So this is going to be 1, the prevalent one here. Let's have it as 1.0. No change in its value, 1.0. And now determine all of these are powers of 10. We can apply our law of indices here. So they are all 10 to the power 8, 10 to the power minus 3, and 10 to the power 15. We have a prevailing 10 to power. What's the resulting power? Law of indices. Let's take the positives together. So we're going to add 8 to 15. 8 plus 15, that gives us 23. 8 plus 15, 23. The 23 resulting minus 3. 23 minus 3 gives us 20. And this is actually in standard form, our final answer. Very simple. So as you can see, the high points once again, Z was standardized from beginning by the appropriate moves as explained. That gave us this Z in standard form. Next, substitution of values, maintaining their powers, evaluation of the powers, elimination of the 64, and then the critical moment, that moment when 10 to the power minus 15 took on position in the numerator, and that made the sign of the power to change from negative 15 into positive 15. Final knockout, retention of the 1 as 1.0 standard form, and now combination of the powers of 10. 8 plus 15, 23, 23 minus 3, 20. Very simple. Let us consider another example. Let's go. Please come with me. That's right. Now we have the traces out of the way so that we can deal with this. All right. Once again, x is equal to 8 times 10 to the power 4. Y is equal to 1.0 times 10 to the power minus 3. And z is 0.0004. Find xy cubed divided by z squared, leaving your answer in standard form. This is a typical exam type question. Let us start straight off. We have x and y already in standard form. All right, so let's conform z to them. Let's conform z, standardize z by the appropriate move. So z should be, can you figure it out? Same way we did in the last example. So let's go. Move the decimal point to where you want it to be, 4.0. So we generate for z 4.0. 4.0, now standard. And now restoration, return to where the decimal point came from. And that is a leftward move, which means a negative power of 10 is required. Negative, and how many digits do we have to move over? 1, 2, 3, 4, and of course 5. Z in standard form. Let's go straight off. We can now do the quick substitution in the given expression. Xy cubed divided by z squared. Let us do quick substitution. Let's go. Fixing the value of x this time around, it is 8 multiplied by 10 to the power 4. Now multiplied by y to the third power. Let us bring in y. We need the bracket, of course. You know why? There is a power on y. So let's go. 1.0 for y times 10 to the power minus 3. With the power prevalent on y, which is the power 3. Maintain the power 3. Now divided by the value of z, which we have standardized already. So we have 4.0 times 10 to the power minus 5. And of course, we have the square on z. That one. Yes, that power. Beautiful. Can you figure out the next move? So what do you think we should do next? Of course, evaluation of the powers. So let the powers, as we have discussed earlier, will be distributed into these terms. All right. So we have, this is going to be 8 times 10 to the power 4 still retained, waiting for the evaluation of the other part of the numerator. So we have times. Let's go. The 1 has to be raised to power 3. 1 to the power 3, 1 multiplying itself 3 times, doesn't change. 1.0 still. times 10 to the power, of course, the 3, we have to multiply the minus 3 within after that law of indices. Minus 3 times 3 gives us minus 9. Now walk through your way into the denominator. The denominator, of course, the square will be distributed. 4 squared straight away, 16. And we have times 10 to the power. And the 2, we have to simply multiply the minus 5. 2 times minus 5 here. And that is minus 10. Now pause the video. Can you figure out what is about to happen? Can you figure it out? Beautiful. Let's go. 8 can check through. 8 goes, divides into 16. That's 2. Beautiful. And now, if we may continue on this part, we have, let us go straight off and move this into the numerator. That's right. So we have, this is going to give us 10 to the power 4. In the numerator, that is that term, multiplied by 1.0. 1.0 is insignificant. I can exclude it, of course. 1 multiplying any figure is still 1. All right. So let us exclude 1. In multiplication, 1 does not add value. 1 times any number is 1. All right. So let's proceed to have 10 to the power negative 9. And now that law, whenever and anytime you have a number raised to power moving from denominator into the numerator area, the only change that occurs is in the sign of the power. Originally negative here will become positive on arrival in the numerator. So we have positive power of 10. All of this divided by 2. And now a very beautiful move. Division by 2 here can be taken care of. Let us cut out a 10 from 10 to the power 4. That's the best move here. So we have an ordinary 10 on 2. Can you see that? So I'm distributing the 2 on a 10, taken from 10 to the power 4. That's right. And then I have multiplied by the remaining part of the denominator, of the numerator rather. So we have 10 to the power 3. Can you figure out what has happened? 10 to the power 3. I took out this 10 from 10 to the power 4. The remaining will be 10 to the power 3. Can you see that? So 10 to the power 3 multiplied by 10 restores 10 to the power 4. So now we have the remaining 10 to the power negative 9 multiplied by 10 to the power 10. That's right. And now you see the beautiful thing about this is that we have a whole number resulting. So 2 divides into 10 straight away. We have 5. Now write the 5 as a single digit before a decimal point to show the standard form. Now the ultimate power of 10 will be by combination of these 3 expressions here. Target is on their powers, of course. Let's take the positive part together. Positive 3 goes with positive 10. So let's go 3 plus 10, that's 13. And 13 minus 9 gives us positive 4. So 10 to the power positive 4. Once again, we have 2 dividing into 10 to give us 5. 5 is best written as 5.0 when we are targeting expression in standard form. And then the combination of the powers of 10 by interactions of their powers. The positive ones, we have to go together. 3 plus 10, that's 13. 13 minus 9 gives us 4. Very simple. Our final answer, very simple. Okay, let's see what is up next for us. All right, one more. The traces, of course, we have to give way. So let us have this. It's a beautiful question. We're given the values of x and y, and we are expected to find the square root of x divided by y. So let us go straight up the square root of x over y. By direct substitution of given values, we can have the square root of x divided by y, square root of the combination. Let's substitute the value of x. We have both values are in standard form. So bring in the value of x. We have 3.2. Now times 10 to the power minus 5 divided by the value of y. The value of y is spelled clearly here. Look at that. We have 8.0 multiplied by 10 to the power 2. This is beautiful. Now, how do we deal with this? How do we deal with this? This is beautiful. So let's go. Now we can see a relationship already. If you ignore the decimal point here, this is 32 once the decimal point is ignored. And this is 8. 8 can divide into 32. So we can use a technique here and make a single movement of the decimal point here forward. Yes, one shift in the numerator and one shift in the denominator. Beautiful. And that's perfect. So you can make equal number of shifts in any term in the numerator and an equal number of shifts of the decimal point in any term in the denominator. So our new face of the problem here is 32. You still have 10 to the power minus 5. And the new face of the problem here is 80 multiplied by 10 to the power 2. Beautiful. Getting the decimal points out of the way. Now, we can already divide at this point, but take a moment to allow 10 in 80 to multiply 10 to the power 2 here. So you're looking at a situation where you have 10 multiplying 10 to the power 2, a transfer of the 0. This is 10 to the power 1. And of course, the law of indices says we must add the powers here. So we have 10 to the power 1 plus 2, and that gives us 3. And now this writing can change, be modified into 32, of course, multiplied by 10 to the power minus 15, divided by, remember, we have taken the 0, load into the 10 to the power 2, so that we have 8 remaining there, multiplied by, of course, 10 to the power 2 has graduated into 10 to the power 3, as we described here. Now we can tidy up this. First division. 8 can divide into 32. Straight away, 8 divides 1 and divides into 32 4 times. 4 times. And take a moment to allow the 10 to the power 3 to relocate itself up. 10 to the power 3 relocate itself into the numerator. If we may continue at this point, we have, this is going to give us the square root of 4 resulting, multiplied by, we already have in the numerator, 10 to the power negative 15. And joining it is 10 to the power negative 3. And can you figure it? You know why it is like this? Of course, 10 to the power 3 moving up, the sign of the 3 will change into minus. Now tidy up this. Take a moment to tidy this up. This is going to give us the square root of 4 multiplied by, what's the prevailing power of 10? Minus 15 plus minus 3. If you take a moment to see that, minus 15 added to minus 3. 2 signs occurring, lock them up. Plus times minus, the negative sign prevails. So minus 15, minus 3, minus 18. That's right. And now we can have the square root of each of them. For the whole number, you can take the square root directly. What is the square root of 4? The square root of 4, 2.0. 2.0. But when it comes to the power of 10, we simply divide the power by 2. Finding the square root, we divide the power by 2. We know that from indices, the square root of any number means that number to the power half. And when half encounters another number in multiplication, it means that number gets divided by 2. So 2 divides into 18, for example. So to find the square root of any expression written to the power, simply divide the power by 2. All right, so we have multiplied by 10 to the power, negative sign sustained, division of 18 by 2, 18 divided by 2, and we have 9. And look clearly, this is actually in standard form, our final answer. Very simple. Okay, so the high points in the problem again, let us go over it. We're looking for the square root of the combination x divided by y. And we're given the values of x and y in standard form, as you can see. Substitution gave us the first move, of course, and now we got involved or interested in the positions of this decimal. So we have to make single shift of the decimal point in the same direction. That gave us 32 up there, and that gave us 80 below. One more move here. The 0 shifted into 10 to the power 2. 10 to the power 2 being multiplied by 10. Here it is. We did it here, and we obtained 10 to the power 3 right there. So 10 to the power 3 came up in the bottom here. And now the division, 8 divided into 32 to generate 4 for us around here. Look at that. And 10 to the power 3, it was time to move upstairs. Move upstairs. That elicited a change in the sign of the power. So 10 to the power 3, going upstairs became 10 to the power minus 3. You can see the appearance of the negative sign. And now take your time to lock the two of them together after the law of indices. 4, square root of 4 retained, that's it, times 10 to the power minus 15 plus minus 3. And we iron it out here. Plus times minus give us the minus in between. Minus 15 minus 3 give us the minus 18 as ultimate power here. That's right. And now it was time to find the square root. For the real number, square root of 4, 2.0. We brought in the decimal point here in order to express our standard form. And now the square root of a number written to a power simply means division of the power by 2. So 18 was divided by 2 here to generate 9 with the sustenance of the negative power. Standard form, our final answer. Very simple. Now, what do we have next? Come with me, stay with me. Okay, so we have another category of example here. Let's take the traces out of the way so that we have working space. Let's go. Get into it. 0.243 multiplied by 0.00064 divided by 0.16 multiplied by 0.9. Let's take the problem again. We expect to leave our final answer in standard form. Let's get into it right away. 0.0243 multiplied by 0.00064 divided by 0.016 multiplied by 0.9. Yeah, the quickest thing to do here is to determine the total number of all digits behind, to the right, rather, to the right of the decimal point. All the digits to the right of the decimal point. Now, in the second writing, this is the decimal point position. All the digits, including this chain of zeros, after the decimal point. Do the same thing in the denominator. Determine the number of digits here combined. That's right. Let's do that. How many digits in total to the right-hand side of the decimal point? Let's go. 1, 2, 3, 4, count with me, 5, 6, 7, 8, and of course 9. Let us just have that written somewhere around here. 9 digits to the right-hand side of the decimal point in the numerator. Do the same thing for the denominator. Let's count. Count with me. Let's go. 1, 2, 3, and of course 4. And now let us have that here. Beautiful. Beautiful. Now we have a total of 9 digits after the decimal point in the numerator. A total of 4 digits after the decimal point in the denominator. The question to answer is, where do we have the greatest value? Of course, 9 is greater than 4. 9 is greater than 4. By what difference? What is the difference? 9 minus 4, 5 is the difference. Beautiful. Now take the step. Write the real digits, non-zero digits in the numerator. Let's go. That means we're going to write 2, 4, 3, excluding the initial chain of zeros, multiplied by now the significant digits again, 6 and 4 alone, excluding the chain of zeros in the beginning. Do the same thing in the denominator. Let's go. This chain of zeros are not significant, so we just write 1 and 6. Or what will you interpret 0, 1, 6 to be? 16, of course. So the 0 is insignificant. Multiply by, and that is just 9. Beautiful. Writing only the significant digits in the numerator and the denominator. And now we have to compensate for the difference, 9 and 4, which is 5. That 5 should be loaded as zeros onto the area where we have minimum or lower number of digits after the decimal point. 5 zeros to compensate the bottom. Let's go. 1, 2, 3, 4, 5. Beautiful. And we can also load this as power of 10, 10 to the power 5. We can do that. But let's have this. Now, Can we see a possible division around? Of course. Can you see? Can you see what I already see? Figure it out. Take a moment. Of course, division. 16 can divide into 64 4 times. Or would you like to be gentle with the division? That's why in one of my videos, I dealt with general requirements for solving problems in science. You have to look for that video. The multiplication table is very, very important. Would you want to be gentle? Okay, you want to divide by 4, and why not? 4 divides into 16, 4. 4 divides into 64. Even if you don't do that, go digit by digit. 4 divides into 6, that's 1. Remainder 2. That 2 remainder by the side of the 4 gives us 24. 4 divides into 24, 6. We have 16 in the numerator. Another round of division. 4 divides 1. 4 divides into 16, that's 4. That's it. So divide according to your capacity. But what a wonderful thing it is if your multiplication table is alive in you. Make it a target. Memorize your multiplication table, at least up to 12 times table. All right. Now look at that. 243 is a common figure. We're familiar with that. 9 can divide into it. 9 divides. Let's go. 9 divides 1 into 9. 1. And now we have 9 goes in 24. 9 in 24. That is 2. And you have the result. 9 times 2 is 18. So 24 minus 18, that leaves 6. 6 by the side of the 3 is 63. 9 goes in 63 7 times. Look at that. Look at that. And now we have, this is going to be in the numerator. 27 multiplies 4. So we can take a moment to quickly determine this. 27 times 4. I go straight off with 4 times 7 gently. I don't want to punch the buttons of a calculator here. So do mental exercise. The brain loves that. The brain loves that. 4 times 7, that's 28. 2 taken over. 4 times 2, that's 8, plus incoming 2, and that is 10. You can see that. Easy job. Now divided by, look at that. 1 with 1, 2, 3, 4, 5 zeros. Can you see that? So we have 5 zeros here. 1 with 5 zeros. What's the trick here now, right now? What's the trick? There are 2 ways to go about this. I want to standardize it, and there are 2 ways to go about it. If I want to standardize this, I have to bring in my decimal point here. So that means dividing by 100. So I'm going to be willing to lose 2 zeros here. So that will make me half, and I'm willing to do that. So this will be 1.08. If I divide so that I have decimals, I have the decimal point after just 1 non-zero digit. Do you see that? So it's a way of dividing by 100. 2 zeros will be lost in the denominator for that. So if I lose 2 zeros, I'll have divided by 1, 2, 3 zeros remaining. That's right. 2 zeros were used in the division to standardize the numerator. All right. And now this can be written as 1.08 divided by 10 to the power 3. That is the meaning of 1,000. 1.0 times 10 to the power 3, simply 10 to the power 3, 3 zeros, that's right. And now you are familiar with this. Should the 10 to the power 3 take on a position in the numerator, we will have the power negated. So a minus will result. And now we have our final answer. This is going to give us, if I may show the final answer here, this will give us 1.08 times 10 to the power negative 3. 10 to the power 3 arriving in the numerator as minus 3. Our final answer in standard form. Very simple. All right. So the high points, determination of the total number of digits after the decimal point to the right. In the numerator, we got 9. Determination of the total number of digits after the decimal point in the denominator, we also got 4. The difference is clear, 5. So write the significant digits, 243 and 64 in the numerator, 16 and 9 in the denominator. Then compensate for the difference. 9 minus 4 is 5, 5 zeros to the one with the lower number of digits after the decimal point, 5 zeros. That's right. Now, reducing terms by division, when we came to this point, then standardization of the numerator by movement of the decimal point 2 places behind. That's a way of dividing by 100. 2 zeros will be lost. By losing 2 zeros here, we have 1, 2, 3 zeros remaining. Expression as power of 10, relocation into the numerator area with concomitant negation of the power on 10. Our final answer. Very simple. Let's see what we have next. All right. So there is a need to subscribe to this channel. Please subscribe to this channel if you have not already subscribed on YouTube. Subscribe to this channel on YouTube. I have a lot of videos in mathematics, physics, chemistry, biology, chess, the game of chess, and of course, handwriting development. I have a lot of inspirational narrations to steer you up, charge up your spirit, drill you to be positive-minded in problem solving in mathematics. Explore the video, explore the channel. All right, so please subscribe and turn on the notification bell. This bell is very important. You get notification as soon as I make a new video. Thank you for subscribing. All right, so let's move on. All right, now it's your turn to practice, and that's the only way you can become an expert. Okay, so on my channel there, you see a narration I did, an inspirational narration according to one of my quotes. I did that. So are you ready? You can pause the video at any time to practice. That's the only way you can become an expert. That's the only way you can move from a learner into a master. So here we are. I've got practice for you. So express each of these in standard form. So more. Simplify this expression, leaving your answer in standard form. More. Yeah, you're giving the value of x here and you're giving the value of y. Evaluate square root of x over y and leave your answer in standard form. I have answer key up there for you. Are you ready? I'm just going to flash that because I want you to solve these problems before you check the answer. So I'm going to flash that, yes. All right. And now let me know if you have any challenges or any request, anything you want me to do, let me know in the comment section, okay? Now here is the quote: mastery and expertise are products of persistence and consistency in practice. You have to keep on the practice, be consistent with it, and be persistent. Don't give up. When you set out to practice, keep up the practice. Do not give up. And mastery is sure. All right. I want to thank you especially for being part of this session. Thank you for watching this video. Please subscribe and follow me for more lessons on YouTube, Facebook, Instagram, TikTok, chess.com, and LinkedIn, of course. You can send me a WhatsApp message if you prefer to do that. You can send me a WhatsApp message if you prefer to do that. Yes. Send me a WhatsApp message. That's the number. That's my WhatsApp number. And of course, you can take a look at some of my publications, some of the books I've written on Amazon. Simply log into Amazon and type Temple AK on Amazon, and then you see a lot of my publications. Follow me as an author. Follow me as an author. I'm going to send an email. That's my email, templeakacademy@gmail.com. Please like, share, and make a comment to engage. Make a comment in the comment section. Don't forget the notification bell. Thank you once again for being part of this session. Until I come your way next time, I'm your regular coach. My name is Temple AK. Stay blessed, remain solid. Keep up the practice.